second of rain.
Hey everyone, welcome back to Homework Genius. In this video, I'm going to show you how to find the component form of a vector. A vector in a plane is a line segment with an assigned direction. So here is a vector on the right where we have 2 points and we know the direction is going from A to B. So we would write our vector using a bold letter. So we'll say U equals AB with an arrow going from A to B on top. And we know here that point A is our initial point and point B is our terminal point. Let's talk about the component form of a vector. A vector V in a plane with an initial point P, x1, y1, and a terminal point Q, x2, y2, we have the formula for a component form of a vector, V equals x2 minus x1 and y2 minus y1. So let me show you what this looks like on a graph. We have a vector V with an initial point P and a terminal point Q. So the x and y values of our initial point here are our x1 and our y1. And our x and y values of our Q point over here are our x2 and our y2. And here is our difference in the x's, and this is our difference in the y's. Let's try an example. We are told to find the component form of the vector u with the initial point of -2, 5, and the terminal point of 3, 7. So in our initial point, this -2 will be our x1, and the 5 will be our y1. And in our terminal point, this 3 will be the x2, and the 7 will be the y2. So to find our vector u, we will go ahead and write the formula above, x2 minus x1 and y2 minus y1. So now let's plug everything in. We have our x2 is 3 minus our x1 is -2, and our y2 is 7 minus our y1, 5. So 3 minus -2 is 5, and 7 minus 5 is 2. So this is our vector u in component form. Let's try another example that's a little bit different. If you have a vector v, 3, 7, that has an initial point of 2, 4, what is the terminal point? So we know from our component form formula, a vector, which in this case is v, equals x2 minus x1 and y2 minus y1. In this case, we were given the vector v, and we were given the initial point, but we weren't given the terminal point. And we know that the terminal point is x2 and y2. So let's start by plugging everything that we know in. So in the place of the vector v, we'll write 3, 7 equals x2, which we don't know, minus x1, which we know is 2, and y2, which we don't know, minus y1, which is 4. So to solve for this x2 and y2, we're going to set all our x's equal to each other and all our y's equal to each other. On the left here, our x is 3 and our y is 7. And on the right, our x's are x2 minus 2 and our y's are y2 minus 4. So let's start with our x's. We'll write 3 equals x2 minus 2. And let's do the same thing for the y's. So we have 7 equals y2 minus 4. And now let's solve for this x2. So let's add 2 on both sides. So x2 equals 3 plus 2, which is 5. So let's solve for this y2. Let's add 4 on both sides. So 7 plus 4 is 11. So our y2 equals 11. Now that we've solved for our x2 and y2, we know our terminal point is 5, 11. Here's the full problem so you can screenshot it for your notes. I hope this video helped. Let me know if you guys have any questions in the comments below. Thanks for watching.